Okay. Last section, we're going to learn about kites and trapezoids. It's our last two shapes. So these are all all quadrilaterals. Quadrilateral is just a fancy word for a polygon with four sides. But we've learned about parallelograms, squares, rectangles, rhombi, plural of rhombuses, and today is kites and trapezoids. And they're all quadrilaterals. Okay. As I said earlier, tomorrow we're going to work on the chapter review in class. Thursday I'm going to go through that with you, and Friday is going to be our test on chapter 6. Okay, so let's talk about kites first. The features of a kite, the two adjacent sides are congruent. It's not opposite now, it's adjacent. And the other two are also congruent. If all four sides were congruent, it would be a rhombus. But if this side and this side is not congruent, they're not congruent to each other, but they're congruent here, it's a kite. Okay? And what's special about it is this angle and this angle are congruent. So that would be the angles between the different side lengths. Okay? What's also special is the diagonal that goes from the one vertex with two congruent sides to the other vertex between two congruent sides splits this angle in equal parts. It's an angle bisector. Okay? This diagonal does not do that necessarily. It's not a given. You can't assume that. But this one does. Okay? And then the other thing that's special is just like in a rhombus and a square, the diagonals intersect at a 90 all the way around. Okay? So just like a rhombus, when you do problems here, you may be given this side is 3, and this side is 4, find this side. Well, if it's a right triangle, if you know your triples, it's a 3, 4, 5, but if you don't, Pythagorean theorem, x squared plus y squared equals z squared, or a squared plus b squared equals c squared. Right? So you'll be having to use the fact those diagonals intersect perpendicularly to solve problems. Okay? So I'll give you a chance to fill your sheet out maybe after I talk about trapezoids, but just be thinking, because some of those questions on the sheet, opposite sides are congruent, opposite sides are parallel, diagonals intersect at a 90, those kinds of questions. You'll have to remember the properties of a kite when you do that row. Okay? The last shape we're going to learn is a trapezoid. And there's controversy in the math world on whether the definition of a trapezoid is one pair of parallel sides or at least one. Because if it's at least one, a square could be called a trapezoid. Right? Because it has at least one pair of parallel sides. I personally use the definition of one pair of parallel sides. Okay? So we know in a trapezoid, the top and bottom are both called bases. Even though we're always used to the bottom being considered the base, in a trapezoid it has two bases, the top base and the bottom base, and those bases are parallel to each other. Okay? There's a special kind of trapezoid called an isosceles trapezoid. And an isosceles trapezoid has the same features that you find in an isosceles triangle. Meaning this side is equal to this side, this angle is equal to that angle. Bases are equal, legs are equal. That's an isosceles trapezoid. Not all trapezoids are isosceles, but if they tell you it's isosceles, you can assume this to be true. Okay? The final feature of a trapezoid is something called the midsegment. The midsegment is a segment that's drawn from the midpoint of both legs. You find the midpoint of both legs, you connect those, that's called the mid-segment. Okay? And to find the length of the mid-segment, you average the length of the bases. Okay? So if this was 3 and this was 6, the mid-segment's 4.5. You add the two bases up and divide by 2. That's how you find the length of the mid-segment. Okay? There's a couple of questions in the big ideas that give you variables. I'm making things up. I have no idea how this is going to turn out. But if I'm given the two bases are equal to, one is 3x plus 2 and one is 4x plus 7, and the mid-segment's 24, how would I set an equation up to solve for x?
For that, right?
Yeah, to find x, what would I do here?
3x plus 2 plus 4x plus 7 equals 24.
Close. It's really close. It's the base 1 plus base 2 over 2. Okay? So you would do 3x plus 2 plus 4x plus 7. And I could either divide by 2 here or recognize to divide by 2 on this side is the same as multiplying by 2 on the other. Right? I don't want to confuse you if that was too big of a jump, but a lot of times if I have a variable expression over 2, it's more complicated to me than just having a single variable expression equal to a number on the other side. So 7x plus 9 is 48. And yeah, got an ugly fraction, but 39/7 is x. Okay, there's a couple of problems on big ideas that you have to use basically the definition of the mid-segment, that is the average of the two bases, to solve for variables like that. Okay. Big ideas is open. I believe CK12 is open. Last section of the chapter, I'll pass out the reviews tomorrow. I would fill out your sheets. If you need any help or you have any questions, ask me. But go ahead and fill the rows out for kites and trapezoids. Yes? Okay.